One last application problem for those rules of exponents. All right. Order of magnitude is used to compare measures and to estimate and perform rough calculations. The order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 105 million is 10 to the 8th, or 1 followed by 8 zeros. So the order of magnitude of 105 million is 10 to the 8th power. The maximum speed of this falcon here is about 90 meters per second. The maximum speed of this garden snail is about 0.01 meter per second. How many orders of magnitude as fast as the falcon is the garden snail? So the first thing we want to do is figure out what is our task. Well, our task is going to be to figure out what is the order of magnitude for the falcon, what is the order of magnitude for the garden snail, and then use our rules of exponents to figure out how many orders of magnitude are between these two. So let's look and set up this problem. The maximum speed of the snail is 0.01 meter per second. So the order of magnitude is a power of 10 that's closest to that. So we're going to have 10, and it's going to have to be taken to -2. Because in order to get this 10 to look like that, we're going to have to move it 2 times. The maximum speed of the falcon is close to 100, and that is 10 squared. Now we're going to put them into a ratio to see how big the difference is between the two. We're comparing the speed of the snail to the speed of the falcon. So the snail goes on top and the falcon goes on bottom. So now we're going to simplify this down here. So we're going to simplify this down, right? So we've got -2 minus 2, which makes it -4. So and then how do we know that this is appropriate? Well, because the snail is much, much, much slower than a falcon.